Welcome to this video on mathematics. The first question here is the dimensions of a rectangle are given as 8 centimeters and 5 centimeters. If A is the area of the rectangle and P is the perimeter, determine the maximum possible value of A divided by P. So this question comes from the topic of approximation and errors, and in this case we are looking at this quotient here. We have A divided by P, and we want to get the maximum value. Okay, a couple of things here to remind ourselves. So if you want, for example, A over P to be maximum, let's say you want it to be maximum, you ensure that A is maximum and P is minimum. So in this case, you're going to have a quotient that is maximum, okay? So this quotient is going to be maximum, okay? So in this case, we have a rectangle which measures actually 8 centimeters by 5 centimeters. So to get maximum area here, that's abbreviated by A max, we have to take the dimensions when they are maximum. So like 8, the least count is 1, so half of the least count is 0.5, so the maximum length here will be 8.5 centimeters. And then we take also the least count to be 1 for this one, so half of the least count is 0.5, so added to the actual value we have actual width to be 5.5 centimeters. Okay, so let's go straight and determine the product of those two. So we have 8.5 times 5.5, that gives us 46.75 centimeters square. So that's the maximum area of the figure. Alright, so let's get the perimeter of the figure. So now perimeter, we know there are two ways of getting the maximum perimeter and minimum perimeter. One way is to make sure that these ones are maximum. We know the formula for the perimeter is equals to 2 into bracket A plus B. So again, the actual perimeter will be equal to 2 into bracket 8 plus 5, and that is going to be equal to 26 centimeters. So if you want to have the maximum perimeter, you can look at the absolute error in the original measurement. You add all of them because you're talking of the sum. So we talked of absolute error here is 0.5, 0.5, 0.5 and 0.5, so the sum will give us 2. So if you want maximum, you would scale this one up by 2. If you want minimum, you subtract 2. So the rounding off error is just plus or minus 2. So if you want minimum perimeter minimum, we're going to take away 2 from 26, and we have 24 centimeters. So now the quotient, maximum quotient, revisiting what we agreed before, that maximum quotient is A max over P minimum, that is a maximum area over minimum perimeter. So this is going to give us, we have 46.75 centimeters square over 24 centimeters. So the quotient is nothing but, let's get now 46.75, we divide by 24, and that is going to give us something like 1.9479 approximately there. So this is the quotient. That is going to be centimeters, because these centimeters have to cancel here. We have 1 centimeter being left. That's how it is done. Okay, let's go to question number 2. This question is coming from the topic of surds, so make sure you are familiar with surds. Okay, all right, you just need to recall the axioms of surds. Just to mention a few, under the solution tab here, we are going to say maybe some axioms. Let's look at some axioms of SADs. If you have, let's say, A times B square root, that's the same as square root of A times square root of B, that's 1. If you have 1 over root A and you have been told to rationalize the denominator, you're supposed to multiply by the conjugate, and actually the conjugate is being mentioned here. So you have the conjugate of A, root A is root A, that gives us root A over root A times root A, and you know very well, again, there is an axiom that should have come here, that root A times root A, the answer is just A. So this one can be applicable here, and we have that. So by so doing, you look at, we don't have the radical in the denominator, so that way we have rationalized. So actually this is now a rationalization of the denominator, just to make sure that we don't have a radical sign in the denominator. So that's what we are going to do here. I haven't exhausted all the axioms, but I can just give a bonus here. We have square root of A over B is same as root A separately, and then root B separately. Okay, that's it. So we just have those. In case another axiom crops up, we are going to look at it. So let's answer the question. We have root 2 minus 2 root 3 is an expression in SAD form, and we have the denominator root 2 plus root 12. Okay, so the requirement is write down the conjugate of the denominator in its simplest form. Okay, so denominator has we have, let me just write here, denominator, we have root 2 plus root 12. Okay, now if you look at this part here, root 12 is the same as root 4 times, under the root we have 4 times 3, because you say 4 times 3 is 12, so you can just dissociate 12 into respective factors 4 and 3, and since the square root of 4 is regular, so we have 2, and then 3 is just going to be a SAD, so we have 2 root 3. So we can simplify this to write root 2 plus 2 root 3, and that checks. Okay, so if that's the case, then we have this other part here. Hence, use the conjugate in one above to rationalize. So the word rationalize, you remember very well, is to make sure that denominator doesn't have this radical sign. So this one, actually this is what we have in the denominator, so we don't want this and that square root sign. Okay, so I'll create some space here for us. We have root 2 minus 2 root 3 all over root 2. Now instead of writing plus root 12, we are going to have what we have obtained here, plus 2 root 3. So you have plus 2 root 3. Okay, so now the conjugate of an expression like this, we look at the sign here. So this is positive, so we are going to alter the sign and make it negative. So this is going to be multiplicable in the numerator and denominator. So we have root 2 minus 2 root 3. We do the same thing to the denominator. Okay, so it's just a matter of multiplying the components in the numerator and the components in the denominator and then simplify. Okay, so what do we have in the numerator? We have root 2 minus 2 root 3. We expand this together with root 2 minus 2 root 3. Now if you look at these two terms, they are similar, so we can use the simple rules of expansion. So if you look at this perfect square for A minus B quantity square. So if you have two quantities A and B subtracted and squared, so then the response to this, or the solution to this, we take the first term square, and that's going to be root 2 quantity square, and then minus, we have a 2 and then we have the product of the first and the last. Okay, so we have root 2, and then we have 2 root 3. Okay, so this 2 is for this one here, so this 2 is this one, so we have plus the last component square, so we have 2 root 3 quantity square. If you do that, so square root of 2, square root of 2 times square root of 2 gives us 2, and we have minus. If you look at this here, it goes hand in hand with the axiom that you just learned here, that you have square root of some number, product of some numbers, it is the same as these two numbers multiplied separately with their radical signs involved. So we have this is like 2 times 2, we have a 4, and then root 2 times root 3, that's root 6. Okay, definitely. So we have plus, and then this we are going to square 2 separately and root 3 separately. So we have 2 square, that's 4. 4 times root 3 times root 3, that's 3. So 4 times 3, that's 12. Okay, so if you evaluate this, you're going to have 14 minus 4 root 6. That's numerator. Now denominator is a difference of squares, because you have root 2 plus 2 root 3 and root 2 minus 2 root 3. So we are going to have this special formula or expression rather. So if you have two numbers a and b, the product of their sum and difference is given by a first one square minus the second term square. Okay, so we have this one here, we square that, and then we minus the second component square, so we have that. So I'm talking of the product of these two, so we have, this is 2 minus 2 squared, that's a 4 times that, we make it 12, right? Just 4 times 3, 12. So you have minus 10. Now, let's take numerator over denominator. So we have, this one is the numerator, so we have 14 minus 4 root 6 all over minus 10. So you can just simplify further. So we know that this term is divisible by 2 and this as well. So we can take minus, 14 divided by 2, that is 7. You have plus, actually this minus will make this one plus. 4 divided by 2, you have 2, then root 6 over 5. So you can just rewrite this one as 2 root 6 minus 7 all over 5. And you can see we don't have a square root symbol in the denominator, so that is now a rationalized function or expression, since we don't have the surd in the denominator. Alright, makes sense. So we have this other question here, number 3. We are told that solve for x in 2 log of x to base 2 the power of 2 minus 7 log of x to base 2 plus log of 8 to base 2 equals 0, and you give your answer in surd form. Okay. Now, solution tab here. So we have 2 into bracket log x to base 2 square minus 7 log of x to base 2 plus log of 8 base 2 equals to 0. Okay, to me that seems to be a quadratic equation. So if you consider this part here, you can see this is log of x, some number x to base 2 quantity square, and we have the same thing here except this part here, which is a constant. So here, since we have the degree being 2, here the degree is 1, so there's a quadratic equation. So what we are going to do, we are going to consider let log of x to base 2, this term here, be equals to k, okay, just an arbitrary value head there. So 2 times that quantity, so this is k, but of course now it will be squared, so you have 2k squared minus 7k plus, so look at this for a moment. We know that 8 is the same as 2 to the power 3. Okay, so log of 8 to base 2 can be written as log of 2 to the power 3 to base 2. And now using the laws of logarithm, we can bring this 3 in front, so you have 3 log of 2 to base 2. Now we also know that log of a number to its base is 1, so this is nothing but 3 times 1, which is 3. So we can replace this one perfectly with 3, and then we get the quadratic equation appearing that way. So this is very simple to simplify. So we have 2k squared minus, so we have to look for the numbers whose product is 6 and sum is negative 7, and those numbers are nothing but minus 1 and minus 6. So we can call this one minus k, minus 6k plus 3. Use factor method to actually factorize this quadratic equation. So having to group those two and those two, we can factor out constant, bring it onto the front part. Have 2k minus 1 minus, so what is common here? We have 6k and 3, so 3 seems to be common, so pull it outside. We have 2k, so that the product will be minus 6, and then minus 1. Okay, when these two terms are the same, so we pick one of them, and then we have this that is onto the outside, and that gives us the product equal to 0. So we have to say either 2k minus 1 equals to 0, and this simply implies that k is a half. Okay, or we have k minus 3 equals to 0, so that also implies that k is 3. Okay, so we have to go back where we presupposed that our log of x to base 2 is k. So we want to find x, so we have when k is a half, so we can say that log of x to base 2 is that k, which is just a half. And using the index notation, because this is now the logarithmic notation, we can say that x is 2 to the power of half. And now this, if you use the laws of indices, this is the same as square root of 2, which is a surd actually. Okay, when k is 3, so we have log of x to base 2 is equals to 3. So again, in index notation, x turns out to be 2 to the power of 3, which is 8. So the value of x is either square root of 2 or 8, right? That makes a lot of sense. Okay, let's go to the last part here involving matrices. So this one involves matrices. So we have matrices. That's the topic. So in matrices, you deal with determinant, inverse, and transformations. Okay, so we have, given that A is equals to 2, 4, 3, 6, and B equals to 11, 3, 4, 1, those are the elements of A and B. Find C such that BC is equals to A. Okay, so we have a product of two matrices B and C to give us A. I just want to remind you that matrices are not commutative, and what I mean by that is that if you have a matrix, let's say, just try solution here. If you have, I'm saying matrices are not commutative. What I mean by this is that if you have a matrix A and then you multiply by B, that is not the same thing as taking B multiplied by A. Alright, so that's very important. So unlike in real numbers, if you have 3 times 4, that's 12, and this is the same as starting with 4 then 3, and this one is not applicable in matrices. So that's very important, you have to note that. Okay, I want to do some illustration here. If you pick B cross C equals to A, let me play with the inverse on both sides, because I know it's easy for me to get the inverse from B here. I can get B inverse. What will happen if you multiply by B inverse to both sides? Like you multiply by inverse of B of this, of that, and then the same thing, B inverse to come to the front, and you multiply by A. So wait for a minute. If you have B inverse times B, the answer is always an identity. And again, identity times a given matrix, the answer is the same matrix. So this is very important, because on the left hand side it will leave us with C alone, and that will have made C the subject of the formula. Unlike in real numbers where you just divide by B both sides and get A over B, but actually we don't have division in matrices. Okay, so it's very clear that now our C value is going to be B inverse times A. So it's just a matter of finding the B inverse from what we are given here. So very quickly, to get inverse of B, we have to get 1 over determinant of B, and then we take the adjoint matrix of that. So we're going to change now the adjoint. So we have here we have D, we have A, this general formula for the inverse of the matrix. Very well, you know how to get the determinant of any given matrix. It will be the product of A and D subtract the product of B and C, and those are the elements we have in B. So very quickly, determinant of B will be 11 times 1, that is 11, minus 4 times 3, which is 12, and this is negative 1. Okay, that checks. Now let's get the inverse. So we have B inverse is going to be equal to we have 1 over negative 1, that's just negative 1. Then we have our D, so we change this one to come here, this one to come here. So we have 1, negative 1, and everything else acquires a negative sign. So we have that and that. If you distribute negative 1 across, you're going to have minus 1, 3, 4, and minus 11. So that's the inverse. Okay, now using that inverse, let's now go back to this equation here. So to get our C value, we have to take this B inverse, that is minus 1, 3. We're about to get to the end of this video, so I hope you're following. So we have that is the B inverse, so multiply by A. So A has the following elements. We have 2, 4, 3, and 6. Okay, alright, so with that we just need to use the laws of multiplying matrices. We start with the row, then column. Okay, so we have minus 3 times 2, that's negative 2. 3 times 3, that's 9. So minus 2 plus 9, that's 7. Okay, just write it here. So here we have 7. Okay, that's the first entry or element of the product. Now we go to minus 1 times 4, that's minus 4. 3 times 6, that is 18. So minus 4 plus 18, that's nothing but 14. Okay, 4 times 2, that is 8. Minus 3 times minus 11 times 3, that is negative 33. So we have 8 and negative 33, that is minus 25. Then finally 4 times 4, that's 16. We have minus 11 times 6, that is negative 66. So 16 minus 66, that is minus 50. Alright, so our answer C has the following elements: 7, 14, minus 25, and minus 50. And that is how it is done. That is quite easily done. Thank you.